All right, so today we're taking a look at 1.2.3. Now remember, we can get to these lessons by clicking on Chapter 1 on the left side of our screen, and then clicking on 1.2.3. So the question is, how can I change the chances? And this is all about modifying the sample space. So it says, if you want to have the best chances of getting a red gumball from a gumball machine, is it better if the machine is full of gumballs or half empty? Do the chances of getting an ace in a deck of playing cards change if you have 3 or 4 decks of cards to choose from instead of only one deck? So in this lesson, we're going to think about the size of the sample space. And the sample space is the collection of all possible outcomes of an event. And if we were to change the sample space, we're going to think about how the whole or total has changed, how the portion or part we are interested in has changed, and then has the event become more or less likely. So remember, when we're talking about likelihood and probability, we have our part or our numerator, which is going to be the outcome that we're hoping for, the desired outcome. And then we have our denominator, which is all of the outcomes total. So we're thinking about how those change as we change our sample space. So this first problem here, 75, it says you will be given a bag of colored blocks, but instead you're just going to click on the Student eTool, and here's your bag of blocks. And when you click on the bag, it's basically like you just reached your hand in and pulled out a block. So like in this case, we just pulled out a yellow block. And then when you click on the bag again, it puts that yellow block back in, and you pull out a different color block. And here we pulled out red. Okay, so that's how the eTool works. Now, what's inside of this bag is listed for us right here. There's 1 yellow block, 2 red blocks, 4 green blocks, and 5 blue blocks. So like first we pulled out a yellow block, but we put it right back in. So there's always going to be a total of 12 blocks in that bag, right? When we add 1 plus 2 plus 4 plus 5, we're going to find our total of 12 blocks in that bag. So the first question here is asking, if you were to reach into the bag and select one block without looking, what is the likelihood that it would be, for example, red or green or blue or orange? So we're going to write a probability fraction for each of these colors. First off, if we're looking at red, I'm going to think about what's going to be my parts. Well, there's 2 red blocks in here, so 2 would be my numerator. And then I'm going to think about what's my total. How many blocks do I have total in this bag? We said there were 12, right? We add up all the blocks together. So my probability would be 2 out of 12. And now I need to think about, can I reduce this? Can I simplify my fraction? So is there a number that goes into both 2 and 12? 2, right? And so I can divide 2 by 2 and 12 by 2, and that should give me my simplified fraction of 1/6. Now, has my probability changed when I went from 2 over 12 to 1 over 6? Or are they the same fraction, the same probability? Okay, that's what we're thinking about here. And then you're going to think about, do these answers above represent theoretical or experimental probability? So here you have to pay close attention to what it's asking in part A. It says, if you were to reach into the bag, so you haven't actually pulled out anything. It's just asking if you were to reach into the bag and select one of the blocks without looking. Would that be example of theoretical or experimental probability? Okay. And then we have 176. It says if you were to select one block from the bag 12 times, replacing the block you drew between each selection, how many of those times would you expect to have selected a blue block? What if you drew 24 times? So again, we're talking about our sample space. All right. So if I drew from the bag 12 times compared to 24 times, is that going to change my probability? Next, we're looking at 177. Now imagine that you and another team have combined the blocks from both of your bags into one bag. You're going to click on this eTool, and boom, now I have my 2 blocks or my two bags, excuse me, put into one giant bag. And so now instead of having 12 blocks in my bag total, I have 24 blocks in my bag. And my new bag contains 2 yellow, 4 red, 8 green, and 10 blue. Notice each of these numbers are just double. So the question is, do you think the larger sample space will change the likelihood of drawing blocks of different colors? You're going to explain your ideas. And then obviously you're not going to be getting a bag of blocks from me. So it's just asking if you were to take that 12, make it 24 total, make it 48 total, are your probabilities or likelihoods changing just because you have more blocks? Or are they staying the same because each of the block numbers are just doubled, like red is doubled, yellow is doubled, blue is doubled. And then you're going to find a theoretical probability of selecting each block, and then finish it off with D and E. All right, problem 178. Even though you combine bags and change the number of selections made, the probability of drawing a blue block remain the same. Do you think the probabilities would change if you combined 3 bags? Why or why not? All right. So again, going back to that last question, go from 12 to 24 to 48 to 64. If we just keep changing that sample space, does it affect the probability? What do you think you could do in order to increase the chances of choosing a blue block? All right. So what would actually increase your chances of choosing a blue block? Next, we have our challenge question, and this is a fun game here. So it says we have a spinner, and we can get there from clicking on this E tool. And if you were to spin on purple, you lose 2 points. You spin on green, you lose 1 point. And when you spin on orange, you get 3 points. So based off this point system and looking at the spinner here with the different probabilities, right? Like the chance of spinning purple would be 1/2. Chance of spinning orange would be 1/6. Green, 2/6. And so based off these point system settings, are you going to be losing points? Are you going to be gaining points? What do you think? You'll end up positive or negative? After you come up with what you think will happen, you're going to go ahead and spin. So like here, I landed on green, so I'm going to start by subtracting 1 point. I'm at -1. And then I'm going to spin it again. And now I'm going to, actually add a point. Every time I land on green, I add a point. So right now I'm at 2 points because I added 1 and 1. Now I'm at purple, so now I got to subtract my 2 points. Now I'm at 0. Landed on purple again, so now I'm at -2, unfortunately. And I keep going and keep going and keep going. See if you find a pattern. Are you going to end negative or are you going to end positive? And then it's really important here that you look at the math notes, okay? These talk about all of the vocabulary that we've talked about so far. Our outcomes, our event, sample space, probability. Now remember, probability can be measured as fractions, decimals, and percentages. In the case of fractions and decimals, that's going to be from 0 to 1, right? Our probability line. 1 is certain, 0 is impossible, and then we have 1/2 in the middle, which would be equally likely. And then we can also write them as percentages. But percent means out of 100, right? Think about how many cents there are in a dollar. There's 100. And so that's why 0.56 goes to 56%, or 21 over 100 goes to 21%. Then we have experimental and theoretical probability. Then you move on to our review and preview. All right. Now remember, you're going to be submitting your review and preview into Canvas. That's how I know that you've completed your work for the day. All right. So good luck. Let me know if you have any questions. Again, this is basically asking if you just change the sample space from like 12 blocks in the bag to 24 blocks in the bag to 64 blocks in the bag, does the number of blocks matter as long as the probabilities are staying the same? All right.